be able to determine the shapes of the first 3 atomic orbitals. For centuries, people have always wondered, what does an atom really look like? Now, we're all familiar with this artist's conception of an atom, which is a nucleus with a bunch of electrons spinning around it. It's kind of the same way that the planets go around the sun. And that's one way to think about what an atom looks like. And also we have the Bohr model of the atom, which shows the different energy levels and the electrons occupying those different energy levels. Now that is more accurate, but it's not really that close to what an atom actually looks like. So what can help us actually visualize the atom more accurately is called the orbital. Now an orbital is a region in the space around the nucleus where an electron is most likely to be found. For example, let's take a look at this model of an atom. It had just a nucleus and an electron cloud. And as you get farther and farther away from the nucleus, the cloud gets less and less dark. So it's darker towards the center and lighter towards the edges. Now, the regions where it's darker, you're more likely to find an electron. So in this atom, you're more likely to find an electron close to the nucleus where that cloud is extremely dark. And as you move away from the nucleus, then you enter the space where you're less likely to find the electron. That's where the cloud is light. And this electron cloud region shows where you're more likely to find an electron, and this is called an orbital. Now orbitals come in different shapes, and so we have the 3 different types of orbitals that we're going to talk about today: the s orbital, the p orbital, and the d orbital. And these orbitals come in different shapes, which highlight different regions in space where you're likely to find an electron. Now here's an image of an s orbital. Now the s orbital is shaped like a sphere, and that sphere represents the region in space where you're likely to find an electron in an atom. And imagine if the nucleus is at the center. And the s orbital can hold up to 2 electrons. The p orbital is slightly more complex. It's shaped like a peanut, and it comes in triplets: px, py, and pz. And as you can see, one of them is pointing straight up and down on the z-axis. The other one is pointing sideways on the x-axis, and the last one is pointing in the other direction on the y-axis. So there are 3 different orientations in space where the p orbital can be found. Now each p orbital can hold 2 electrons. So if each can hold 2, and we have 3 different p orbitals, then the p orbital can hold a total of 6 electrons. And finally, the d orbital. The d orbital is even more complex. And as you can see, they're shaped like propellers. So these propellers demonstrate in the area in space where you're likely to find an electron. They come in 5, so the d orbital always has 5 of them pointing in different directions, as you can see, and the 5th one is kind of different shape altogether. Now each suborbital can hold 2 electrons. So if there are 5 suborbitals and each one can hold 2 electrons, then the d orbitals can hold a total of 10 electrons.